In this video, I'm going to continue talking about rule locus. So this is the second part of rule locus. So here's a recap of what we talked about in the previous video on the rule locus. So rule locus talks about how do the poles of a closed loop system, a unit negative feedback closed loop system, would change if my proportional control parameter k moves from 0 to infinity. So this figure shows what is the general setup, what is a classic setup for the rule locus. We have a unit negative feedback. We have given a system given by g sub s, which is represented by p sets of s divided by q sub s. So both p sets and q sets, they are polynomial of s. So this is a g sub is not the closed loop transfer function. The closed loop transfer function is given by y sub s divided by u sub s. By using the block diagram, we know that this transfer function is given by k times g sub s divided by 1 plus k times g sub s. Okay, so the rule locus talk about if I give different k, how do the poles of the closed loop transfer function would change as my k increases from 0 to infinity. For example, I'll give an example showing that how the poles would change if I say, for example, when k is 1, I can draw the poles. When k is 10, I can draw the poles again. So you basically can see as k change, the pole will move. Okay, so the rule locus talk about how the poles will move as we increase the k from 0 to infinity. So in the previous video, I talked about the first 4 rules in the plotting of the rule locus. Okay, so here's a brief recap of these 4 rules, and the details are given in the previous video if you want to know what the 4 rules are about in more details. So the first rule says there are as many lines or loci as the degree of PS or QS, whichever is greater, which means how many of these lines in my rule locus. It depends on how the degree of PS of Q or Q of S, whichever is larger. So if I have 3 poles or 3 zeros, I should have 3 lines. If I have 3 poles or 2 zeros, I also have 3 lines. If I have 2 poles, 3 zeros, I also have 3 lines. Okay, that's the principle, the first rule. Okay, so typically we use x to represent poles, use zeros, circle to represent zeros. So for this case, if I have 3 poles, 2 zeros, so I have 3 lines and loci. Or I have 3 loci. The second one rule says rule locus or lines always start with the poles and end at zeros. Okay, so for example, if I only have 1 0 and 1 pole, now the rule locus or the line is just given by starting from the pole ending at 0. So when I say the pole and 0, I mean the pole of g sub s. The 0, I mean 0 of g sub s. I don't mean by pole 0 of the closed loop one. It's an open loop one, basically the g sub s. Okay. The rule number 3 says rule loci come with conjugate pairs if the roots or poles are complex, which is very easy to understand because the root loci talk about the poles of the transfer function. Because we know the transfer function was given by polynomials, right? Which is equal to 0, right? With real coefficients. This will always admit complex conjugate pairs as poles. That's why it's always symmetric along the real axis. Which means, for example, if I have here this pole is one of the poles of closed loop transfer function is, let's say this is 3 plus 2i. So I must have another one which this guy is 3 minus 2i. This is what I mean by complex conjugate, which means if I a plus b times I, so this I is equal to square root of negative 1, is a pole that must have a minus bi is a pole. Okay. The rule number 4 says a single line cannot cross over itself, which means so you can sort of interpret this a single line is represent one single. This is a, which means a single pole change with respect to k moves from 0 to infinity. So the line or Loci actually talks about, let's say for example here, if you k start from 1, let's say a general sense, if you k starting, let's say from somewhere, let's say this is 1k0, okay, for one pole, you compute that. So as time goes on, you see this is trajectory. Let's say this is trajectory. Oh yeah, this is called a line. Okay, this is line. The other one, you could have another one. You start another pole. You start from here, 1k0, but this pole will move to according to this line. You could also have another one. It's right over here, so it goes this way. That's also called a line. So a line represents how one pole changes with respect to the parameter k. Okay, so one single line does not cross over the cell, which means can go back to once this pole, which means if this number appears already, this is a one pole, right? For some k you have this value, which means you only have a unique k which will give this value. You cannot have k1, you got this point, and also for some reason you have k2, their point, they meaning the same point. This is not true. This won't happen. This won't happen. So now I'm going to continue to talk about additional rules. So I will talk about rule number 5, rule number 6, rule number 7, and rule number 8. The rule number 8 is a little bit complex, so it takes a little bit more time. So let's talk about those rules. So rule number 5 says the portion of the real axis to the left of an odd number of the poles and the zero are part of the Locator lines. Okay, this rule is reads a little bit complicated, but when I explain it, it's fairly easy to understand. Okay, so first of all is an odd number of the poles and zeros. So first of all, I'm going to draw all the poles and zeros on the real axis. Okay. For example, if I have this one pole, 1, 0, I'm going to draw all the poles on the real axis. Okay? What it says, to the left of an odd number, so we have to number it. Okay? So we number the poles from the right to left. This is the direction we should use, from right to left. Okay, we name it. Says this is the first one, this is 2. So you don't distinguish between poles and zeros. They are all doesn't matter. So you just give when you have 1, doesn't matter if it's row 0 and pole, you just add on, it increases your index by 1. For example, here I have a 1, 0, 1, 0, and 4 poles, basically, right? I can name it 1, 2, 3, and 4, and 5. Okay, you name it, then you find the odd number. So this is odd numbers is 1, 3, 5. Well, this is for this case is 1. Now it says the left of an odd number of the poles or zeros are part of Loci, or real part, real axis. For example, here, you know it's going to be here, right? So because this is to the left of the, between 0 and this is to the left, right, of the odd number. But this one doesn't account because this one is to the even, right? Similarly, between 3 and 4, also to the left, right? So this one is also part of Loci. And then to the left, this is also part of Loci, right? So this is all part of the Loci. So you sort of see this part, if I do this one, this part, let's do this. This part is part of Loci because it is to the left of the odd number 1. This is also part of Loci, is to the left of odd number 3. This is also part of Loci because all the way to the infinity, of course, because to the left of odd number 5. For this one, is just between 0 and 1 or 2. It is part of Loci. This is part because it's between 1 and 2. Actually, for this one, if I only have 1, 0 and 1 pole, this is exactly going to be the line, or I call Loci, because this real part must be part of Loci. Okay, must be part. And also, the rule number 1 says, not rule number 1, number 2 says you must start with a pole and end at 0, right? You start at the pole, right? Start at the pole, end at 0. That's why it's going from here to here, which means as k, for this case, if I have 1 pole here, 1, 0 here, as k goes from 0 to infinity, this is how the pole will change. Going to go this way and then stop at this point. Okay, Let's take a look at this one. This is a little bit more complex, okay? So again, I can see this part is part of Loci because it's according to the rule number 5. Also, this is part of Loci, and also this is part of the Loci, of course, to infinity, definitely to infinity. Now I could say this is part of Loci. This is, I draw this line because according to rule number 2, it must starting from pole ending at 0. That's it. Similar for this one, start for 0 and go to infinity, right? Yeah, because I have no more zeros, so it will go, for others it will go to infinity. Okay, it will go to infinity, so that's one of the line. So for these two lines, okay, for this two line in between, so I have this one over here is in between, right? Because I know the rule is I start from pole and ending at zeros, right? But I don't have zeros, it will go to infinity. They all talk about more rules later on. But generally speaking, it will go up and go down, a split at a certain point, and go up and down. Okay, so in terms of what direction is going and how gonna split and what is the angle, all the stuff is going to be given in the next several rules. That's why this is not sufficient yet. We have to talk about more rules because for this case, it's not covered in the existing rules yet. Okay, so rule number 6, exactly trying to answer part of this question I mentioned over here. It says Loci or lines leave, which means break out, or enter, which means break in, the real axis at 90 degrees, which means whatever it leaves this real axis, it's going to be 90 degrees, exactly what's meant to be. So this will be 90 degrees, is given by rule number 6, okay? So for example, if I will give you g sub s is 3 times s plus 10 divided by s plus 3 and s minus 1, okay, so I can draw the poles. So I have two poles, which is s is negative 3, s is positive 1. I have 1, 0, which is s is negative 10 over here. So if I draw it over here, what's happening is I have two poles, 1, 0, okay? So according to rule number 5, I know and lay a number it. This is number 1, this is number 2, this is number 3. So to the left of the real odd number of 0 poles are part of the Loci. Okay, so real axis. So this part has to be part of Loci. Okay, and also this is part of the Loci. Okay, right? Now what's going to happen is, because the pole, the rule number 2 says my line Loci must starting at the pole the ending of zeros or ending of infinity if you don't have enough zeros, right? So it's going to going here. So you don't consider this one will go from negative 3 to 1 because you cannot go from pole to pole. You must go from pole to 0. So pole go here, and it somehow must split. Otherwise, it cannot stay here. It has to go to 0, right? Or go to infinity, right? So what is going to happen is must leave the real axis. If it doesn't leave axis, it's going to stay here forever. So it has to leave. So at a certain point, it's going to leave. But when it leaves the real axis, it's going to add 90 degrees. So because of symmetric, again, because this guy, according to the rule number 3, so it must be symmetric, which means I must have somehow one going up, one going down. They are symmetric. And then they'll go back. Otherwise, they wouldn't go to 0, right? They should go to this 0, right? So they should go back to the 0 here and then try to stop at 0, which means I have somehow like this. This one of the pole, one of the line. The other one is going here. So if I draw this a little bit clear, so somehow like this. This one goes here and going up, and then going over here. The other one trying to go somehow differently. It's going here and going down, and going this one, because this one will go to infinity. Okay. So this is rule number 6. The rule number 7 says if there are not enough 0 on the pole, or zeros poles or 0 to make a pair, the extra line go to or come from infinity. This is exactly what's going to why this one go to infinity. This one go to infinity. So when it's going infinity, it could go up and down. It doesn't mean it's always go to infinity along the axis. It can go up like that. Okay, I'll give you more example for rule number 8. So they are not, which means, for example, if I only have one pole over here, okay, what's going to happen? So according to rule number 5, it says to the left of the odd number of 0 on the pole will be part of on the real axis, part of Loci, right? Because this is pole 1 is here, number 1 to the left will always be part of Loci. That's why this is part of Loci. So the entire one goes to infinity. According to this rule, it go to negative infinity. So for this one, I have two poles, okay, and it will go up and down. This rule says it must go up and down, right? Also here it says it must be 90 degrees, okay, once they leave 90 degrees, right? Okay, of course, can it go something like this, leave but then start to get something like this? Would that be possible? So this is not possible for this case, because I'm going to talk about more detail in the next rule. Talk about what's the direction that this is going to, if it's going to infinity. Okay, so just because this will go up directly. Okay, so for this case, you can also say the system is always unstable because it's starting with a positive pole, k0. It doesn't matter what k value we have. It's always either go up and go down, so it never go to the left this side, because I want this pole to be on this side. This is domain. I want this pole to be in, right? But it never goes to this left hand side. That's why for this system it never be stable it will never be stable. It doesn't matter what k we have. Okay, so now let's go to the rule number 8. It's the most complicated one for the rules that we talk about so far. So it says the line and locus go to infinity along asymptotes, and the angle of the asymptote is given by phi a is 2q plus 1 divided by n minus m times 180, where q is from 0, 1 to n minus m minus 1. Now the centroid of all asymptotes is given by this value. So which means, before I talk about the detail, what it says is you can have different angle. Your angle can be different because this will give different angle, but the centroid will be always the same. The centroid share the same for all the lines. If they move to infinity, they share the same centroid for the asymptotes. So here give a description about what is a kind of understanding. This is not a formal definition, but this is what I mean by asymptotes. So if we give, let's say, a blue line, which is, let's say, the line of Locus, okay, what is trying to say is this. Suppose this is a line we have for our Locus. So this line will gradually approach some line. Okay, some line. This is called asymptotes. So it's gonna gradually approach some line. So eventually this blue line will be the same, has the same pattern of this line. Although it doesn't share the same pattern at the very beginning, but eventually it will same. This is called asymptotes. So the asymptote, this line has a point over here, right? And also angles. This is a point, this is angle determines the uniqueness of the asymptotes. Okay? So which means I can confidently say what the angle will be, what the root line will look like eventually as time goes on. Okay. So let's talk about a more detail. Give an example showing what this, how to compute this angle and centroid and how to draw the line, because this is a very complicated one. Okay, so without talking about all those variables over here, I'm going to go over an example and I'll explain what those numbers are, what those variables are. Okay. So let's start with a simple case when I only have one pole. Okay, and now we already know how to draw this, because if this one is my pole, so this is number 1. I know that all the left will be myself, will be part of Locus, and it will go to infinity according to rule number 7. This is already done, but we can also use the rule number 8 to check it. So what this one says, go to infinity along this one also, because any line goes to infinity will move along asymptotes, or maybe it could be the same as the asymptotes. Okay. And the angle, let's compute the angle of the asymptotes given by phi a is 2q plus 1 time divided by n minus 1 times 180. So q can be selected from 0, 1 until n minus 1, n minus m, and n minus 1. So what is n? This n is number of poles, m is number of zeros. Okay, so for this case, n is 1 because I have one pole. M is 0, I don't have a 0, so it's m is 0. So n minus m is 1. Okay, so here it says I can select q from 0, 1, so on and so forth until what? Until n minus m minus 1. So I start from 0, blah blah blah. So I have stopped at 0 because n minus m for this one, n minus m minus 1 0, right? You start from 0, you cannot add up more anymore because you have to increase by 1, but when it increases by 1, this 1 is already greater than this 0, so you only have one value over here. So which means I can only select q to be 0. Okay, that's only value, so I can do that. Okay, so q is 0, so qa is 2q plus 1, so q is here, q is 0, and n minus m, n is 1, m is 0, we already get that. Time 180, so it's 2 times 0 plus 1 divided by 1 time 180, so this is 0. So it's 1 divided by 1 time 180 is 180 degrees. So we know it's going to be this direction, 180 degrees. So this degree is a theta, right? So 180 is going to be this line. You know that. So now let's compute the centroid of the asymptotes. The centroid is just the summation of all the poles minus the summation of all the zeros. Okay, so the poles, we have poles are given by, this here is -2, this pole, right? This is -2, no zero, so this is gone. So it's poles -2, and then divided by n minus m is just 1, so it is 1, so it's -2. So you sort of say, oh, my line will be eventually approach this line. It's starting from -2 is 180 degrees. So you're gonna this line, which is actually matches the asymptotes, right? Exactly the same asymptotes. The line will match the asymptotes. Okay. So this is quite simple. Now let's look at the second example. What if I have two poles but non-zeros? Okay, so this is what we sort of mentioned over here. Okay, we'll talk about that. So for this case, we have, remember, n is number of poles. This is number of zeros. So the number of poles is 2. We have 2 poles. Number of zeros, 0. Don't have zeros. So let's say Q can be selected from 0 to 1 until n minus m minus 1. So you can, so the upper limit of is this value. So n minus m is 2 minus 0, minus 1 is 1. So you can only do 0, 1, blah, 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 you do 1 until 1. So you only have 2 values. So you can select Q is 0 and Q is 1. The 2 value. You cannot do Q is 2. Q2 is greater than this value. You cannot. Is larger than n minus 1 minus 1. You can only select Q from 0 until n minus m minus 1. Okay? Alright? So that's why I have Q is 0, Q is 1. Okay? So I have 2 angles. We'll compute the 2 angles separately. So phi A1 is the first angle. So this one is, I set Q is 0. Basically, I compute what's the value. And this guy is Q is 1. Okay? So I do 2Q plus 1 is 2 times 0 plus 1 divided by 2 minus 1. 0 times 180 degrees is 1/2 times 180 is 90 degrees. So I know one of them is going to somehow, the asymptote is going up. Say it's going up, somehow 90 degrees. Okay, let's compute the second angle before talking about centroid. So phi A2 is just replace Q by 1. So it's 2 times 1 plus 1 divided by 1 2 minus 0 times 180. So you can divide it as 270 degrees. So one is going up, one is going down. Okay. Let's now compute the centroid. The centroid here says is the sum of the poles minus sum of the 0 divided by m minus m. So the poles are -2, -1. So I'll give you an example. -2 plus -1 divided by 0 is gone. No 0, right? So m minus m is 2. So it's -2 plus -1 divided by 2 is -3 over 2. It's just in the middle. So the two asymptotes are, one of them is starting over here, going up. One of them is starting from here, going down, all the way down. Okay? So that's it will approach that. Actually, what's happening is going to exactly match that, because they're going to split right in the middle, and then one going up, one going down. Okay. Alright, now let's take a look at more complicated ones. This will be more complicated than the second case. Is when we have 3 poles, and one of them, and then we have non-zeros. Okay, so here for this case I have 3 poles. They are at -1, -2, -3. Okay, so that's 3 poles, and we can compute an n and m. N is again the number of poles. The m is the number of zeros. So I have n minus m is 3. Okay, so let's compute the angle. So again, so Q can be selected from 0 to 1 until n minus m. n minus 1. n minus m is 3, minus 1 is 2. So I can select Q is 0, 1, 2, 3, 4, but the upper limit is 2. So I can only select Q is 0, 1, 2. That's what I select. So I have 3 angles. Okay, without going into the detail, you do all the calculation again. Without going to the detail, I have QA1, you can compute that. 2 times Q plus 1 divided by 3 times 180, you have 60 degrees, 180 degrees, and 300 degrees. Okay, that's what we have for the angles of the asymptotes. For the centroid is given by sum of the poles minus sum of the zeros divided by m minus m. So the poles are -1 plus -2 plus -3, that's the sum of poles. The zeros are gone, we don't have zeros. And divide by m minus m, which is 3 here. So if we do the calculation, it will give us the -2. So I have 3 asymptotes. I draw it over here in the blue line over here, a blue dashed line over here. So it's centered at -2, and this one is 60 degrees. One is this is 180 degrees. This is 300 degrees. I have 3 of them. So if you look at let's talk about a rule. So rule number 5. Number 5 said, let me make sure this is rule number 5. Yes, rule number 5 says to the left of the odd number of the zero poles are part of the real axis, part of Loci. So they are all on the real axis. So this is 1, 2, and 3. Okay, so this is to the left of the real part. Odd number of the zero poles on the real axis. This is part of Loci. Also, this also is part of Loci. Of course, it will go to infinity, right? Again, because this one, rule number 7 says that whatever, if you don't have enough zero poles, this one will go to infinity, right? So this is one of the line of Loci. For this guy, because we know it's going to approach these 2 lines, right? So this one must split at a certain point, then try to approach the line. Of course, I don't know when it's gonna split. This one part it doesn't mean it's in the middle. It may to left and right. Okay. So it could go here and it go here and here. So this one, why the rule locus is important? Because if you look at this one, so for this line, it doesn't matter for whatever k, you all have a negative real parts on the left hand side. However, for these two lines, you know, at a certain point, certain k, because this is as time goes on, as k increases, right? It's going to this direction. So you know, at a certain k, you're gonna cross this imaginary axis. So this is a critical point when you become unstable. If you pass the point, you have positive real parts for your pole, the poles of the closure of trans function. So there's a critical value of k beyond which you will be unstable, and less than that it will be stable, right? Because the poles are stayed on the open left half plane. Okay, so that's also why we can see what's going to happen. For certain cases, k has to be greater than something. For certain cases, k has to be less. So you can use the rule locus to view what is the typical range of k. Okay. So I'm going to the last one, which is when we have 4 poles but non-zeros. Okay. So I pose at 1, 2, -1, -2. I don't have a 0. Okay. Again, so the n is 4. This is the number of poles. This is the number of zeros. Okay, so the centroid, I just computed. The centroid is the number of poles minus number of 0. Again, the number of 0, the sum of 0. I'm sorry, the sum of poles minus sum of 0. They don't have 0, so it's 0. The sum of poles is just the sum of them together. So because the sum is 0, like -2 plus -1 plus 1 plus 2 divided by 4 minus 1 is 0. Okay, this is a 0. The centroid is 0. And I have a phi of A, the angle, right? Apparently, you can see there must be 4 angles, right? But according to the angles of the asymptotes, so Q has to be start from 0, 1 until n minus 1 minus n minus m minus 1. So n is 4, m is 0. So 4 minus 0 is 4, minus 1 is 3. So I have Q start from 0, increase by 1 by 1 by 1 until I got 3, right? So I have 0, 1, 2, and 3. So I have 4 angles. That's correct. So the 4 angles are computed by exactly the same way. It's 2q plus 1 divided by n minus m times 180. So this is when q is 0, q is 1, q is 2, and q is 3. So this is what we have. So if you compute, you got 4 values. They are 45, 135, 225, and 315. Okay. So if you draw these numbers right over here, so I have central. If I draw the asymptotes, okay, I start from here. One is 45 degrees, one is 135, one is 225, and one is 315. Okay, how do I draw the rule locus? Okay, so you actually, according to the rule number 5, so this is the to the odd number, to the left part of the odd number of real and the poles and zeros are part of the Loci. So this is part of the Loci because this is to the left of rule number 1. Okay, this is also part of Loci, so also is number 3, right? So we sort of can see somehow this guy will going to approach and going up and going this way. Okay, one is they're going to because they're going to move from 0 according to rule number 7. This one will go to infinity, right? So this one go together and split, and then one going up, one going down. Okay, similar for here, they're going to move to a certain point and to 0 axis, then split, and one going up, one going down. Also, this is 90 degrees according to it's 90 degrees, right? According to rule number 6, right? 90 degrees. Yes, this all be 90 degrees. This also 90 degrees, and this 90 degrees. Okay. So this is for the fourth case. You can also do the same case for number 5 poles, non-zeros, so on and so forth. So here I'm going to take one more example. Give one, both have 0 and poles. Now, the previous case I just show you the only poles, no zeros. Now I'm going to show you one have zeros. Okay. So I have, let's say I have 2 poles, one which are given by 1 and negative 1, and 0 is given by negative 3. Okay, so for this case, my n is, again, this n is number of poles, so which is 1. I have 1 pole. M is number of zeros, so it's 1 because I have 1 0. So n minus m is 1. Okay, my angle is just given by 2q plus 1 divided by n minus 180, and q has to be selected from 0 until n minus m minus 1. Because n minus m minus 1 is 0, so you start from 0, you just stop, because you cannot keep on moving anymore, because otherwise you have 1. 1 is greater than n minus m minus 1. So it's q is only equal to 0. Okay? If you replace by q, I got the angle phi a is 2 times 0 plus 1 divided by 1 times 180 is 180 degrees. This is 180 degrees. The centroid will be just the sum of the poles minus the sum of zeros. Okay, the sum of poles are given by negative 1 plus 1. Okay, 0 is negative 3, so minus negative 3 is divided by 2 minus 1. So this gives us 3. So you also can see my asymptotes is, suppose it's 3. So I'm going to 3, go 180 degrees, going all the left. This is my asymptotes. Okay. So if I give this one according to rule number 5, to the left of the order number of the zeros and rows on the real axis will be part of locus, which means this is a, let me use a purple color. So this is part of locus because this is number 1, so it's to the left, yes. And also we know to this part to the left is also part of the locus, all the way to the infinity, right? So we know because the rule number 2 says the line or locus must start from the pole but ending of 0 or ending infinity according to the rule number 7. So it must split, otherwise it doesn't go to 0, it doesn't go to infinity. So it's gonna split, one go up, one go down, also symmetric. Okay, and one of them is going to 0, one of them going to infinity. This one go to infinity, that makes sense because it actually approach asymptotes along the axis. Actually it's like it is exactly the same as asymptotes determined by the 3 central 3 and the angle is 180 degrees. So it's going to be like this. So one of them, if I draw it clearly, one of them going here, going up, and then stop over here. The other one will be going here, going down, and go to infinity. So that will be the 2 lines. Okay, as you can see from here, even if I have 2 poles, they are starting from, one of them is positive, one is negative, which means K0, if I give you a conclusion, K0, this is unstable. That's because I have just poles here and here, right? So one is positive. However, if I let K increases, start going here, move together, and start to go here. So it start to move to the left hand side. So which means at a certain point, once K approach, for certain K, once this line move to the left of the imagined axis, then becomes, there's a critical point. So this is a K star. For some K star, you move over here. So as long as I have a K greater than K star, so I'm unstable. As a matter of fact, you can also say as K moves even larger, for example, let it keep on moving, it starts to move even left, right? Even left here and here, right? You sort of can see once the K is large, say this is a critical point, this is also another K star. So when K is greater than K star some value, you can see you have 2 negative. So one is going here, right? One is going to infinity, right? Which means you have 2 real and negative poles. So for this case, you can say, of course, it's stable. and also there's no oscillation. So your system does not emit oscillations. That's why, by drawing the root locus, we can get a lot of ideas about how we select this k. So if you don't want to have an oscillation, you want to select k is greater than that, of course. And also it's to provide a better stability because it's really far away from the imaginary axis. So this is also preferred. Okay, so I hope this give you a little better idea about how to use the locus, the 8 rules that I talk about so far about how to draw the root locus.